Lesson 2.7. Today we're going to briefly look at the periodic table. Periodic tables will differ according to whatever source you get them from, but all periodic tables in each box should have the element symbol and the atomic number, or how many protons are in there. Some may also include the element name, some may include the atomic mass, but every periodic table should at least have the atomic number and the atomic symbol. This is a picture of a periodic table, and we're just going to talk about a couple things briefly, and then we'll move on, finish this PowerPoint, and then I'll come back and include some more things about the periodic table. First off, we're going to talk about metals versus nonmetals, and as I mentioned before, there's a stair-step line, and if it's not actually drawn on a periodic table, then you can kind of mimic that stair-step line. As long as you can get it started knowing that it goes between boron and aluminum, then you can stair-step it down. And generally, the reason it doesn't go on is because these are relatively new elements that have been discovered, and so they don't last long enough to really classify them. But anyway, these are the nonmetals over here, and these are all of these are the metals. So if I said to you, I'm thinking of an element from the periodic table, and you had to guess, like you're going to win $100 if you could guess whether it's a metal or non-metal. Obviously, there's so many more metals on the periodic table that it'd benefit you a great deal to guess a metal. Please note that hydrogen is over here. Hydrogen is not a metal. Hydrogen is kind of its own little species, and it sits there because of its outer electron shells. So metals versus nonmetals, other than what we're going to talk about when we talk about compounds and the fact that it tends to lose electrons and this one tends to gain electrons, metals and nonmetals have other properties. Metals are good conductors. They conduct both heat and electricity. They're malleable, which means you can smash them into fine sheets, and ductile, where you can draw them into wires. Metals are generally shiny. They have a lustrous appearance, and they will lose electrons to become more stable and form positive ions. Nonmetals, on the other hand, are basically just kind of defined as they don't have these properties. So they're not good conductors of heat, electricity. They're not malleable. They're not ductile. They tend to gain electrons when they react with metals to form negative ions, and nonmetals have the ability to form covalent bonds with one another. So the periodic table, if you have a periodic table in front of you, you can gather a lot of information from it. One of the things is the group names or group numbers, mainly on a periodic table. The names you kind of have to know. The reason that elements are grouped a certain way is because they react similarly. They have the same outer shell electrons. So the first group we're going to talk about is group 1A. These are the alkali metals. Notice that hydrogen is not up here. Group 1 metals, group 1A metals, the alkali metals, are very, very reactive. I don't know if you've seen a demonstration of sodium in water, but sodium is very, very reactive with water. It doesn't take much for it to give up that electron, and it's a very exothermic reaction. And so these things, when they are in ionic compounds, will form +1 ions. The second group, group 2A or group 2, are the alkaline earth metals, and they call these such because a lot of these metals are found in the crust of our earth. And these alkaline earth metals will have a +2 charge when they react with nonmetals. And then we move clear to the right on the periodic table. The noble gases are group 17 or 7A. When they react, they form ions with a -1 charge because it's very easy for them to gain an electron so they can become stable like these noble gases. Noble gases are group 18 or 8A. These elements have a full outer shell of electrons, and so you can get them to react, but they don't do a whole lot of reacting because they're stable the way they are. The periodic table also has horizontal rows. The horizontal rows, what they're doing is they're filling a certain electron shell, and that means there's really no chemical similarities. The only thing is they're filling the same shell. If you're in the same row, you're basically filling the same shell. And these are pretty easy to name because you just number down the side of your periodic table, and that tells us which row they're in or which period they're in. So which of these form ions with a +2 charge when they react with nonmetals? If you guessed B, you guessed correctly. The alkaline earth metals, or group 2, are the ones that form a +2. So let's quickly go back to that periodic table and talk about a few other things that weren't mentioned necessarily in the PowerPoint slide. So there was your alkaline metals, alkaline earth metals, halogens, noble gases, metalloids. Metalloids tend to have properties of both metals and nonmetals. For example, silicon is very shiny, but when you hit it with a hammer, it shatters. It's not malleable at all. So shiny like a metal, but not malleable like a nonmetal. But these particular nonmetals do have really good properties that allow us to do certain things with them, like make semiconductors. Aluminum, even though it's next to the stair-step line, aluminum is a metal. Another thing I want you to look at is transition metals. Transition metals actually kind of move over here a little bit too. Transition metals have a tendency to have different charges. So, for example, iron can be a +2 or a +3. And when we talk about naming compounds, we'll talk about something called a stock system, which forces us to tell you in the name of a compound what the charge is on that ion. Down here we have the lanthanides and the actinides. These two columns would actually fit right here in the periodic table, but it would make it so wide it would be unmanageable. And I think that's probably all I want to share right now. We will, in the next lesson, start naming compounds, and then lessons will be short, but you need to practice each of the different types of naming as we go along, and that way we can tie it all together in the end. That concludes lesson 2.7.